Okay, la lesson yethu izobe based manje kuma physical properties sayona organic chemistry. So what are physical properties? It is what define kanjena kuthiwa each chemical compound has a physical property such that its phase, melting point, boiling point, vapor pressure, viscosity, density, and solubility. Note that the type of bonds affect all these properties. So i-topic yethu nje based kakhulukazi kwi-phase, kwi-melting point, boiling point, vapor pressure. Kodwa lokhu i-density ne-viscosity ngeke i-focus kakhulu, izobe based nje kakhulukazi ku-melting point, boiling point, ne-vapor pressure. These properties are affected by the strength of intermolecular forces, and then we focus also on intermolecular forces between the molecules of in the compound. So kubalekile nje ne-revision yakho for ama-intermolecular forces fanele uyi-graspe, uyi-understand. So nansi yokuqala intermolecular forces. There are 3 types of intermolecular forces, and then khona ama-van der Waals dispersion forces, okwenkathi abizwa ngama-London forces. Kuba khona nama-van der Waals forces abizwa ngama-dipole forces, okanye kube khona ama-induced dipole forces, and then ekugcineni kube khona ama-hydrogen bond. So the weakest one njengoba indicated la ngaleya inequality sign leya emele ukuthi this one is the strongest, le weaker than ama-hydrogen bond, le ama-dipole are stronger than ama-London forces. And ama-London forces kukhona ama-alkanes, alkenes, nama-alkynes, and alkyl parts of the molecular forces. Enzeka kanjani yona? They occur between temporal induced dipoles in non-polar molecules. So injalo nje, they occur between temporal induced dipole in non-polar molecules. And then van der Waals ama-dipole forces occur between permanent dipoles of polar molecules. La bekwa non-polar, but in this case they are polar molecules. And logo into ebalekile nje ukubona ukuthi okay ukiphi ke manje into ebalekile ukubona ukuthi is it ama-haloalkane, ama-aldehyde, ama-ketones, and then siyowazi ke wena ukuthi under ama-dipole forces khona o-haloalkanes, aldehydes, ketones, nama-esters. And then sizela ekugcineni kuma-hydrogen bond occurs between molecules with hydrogen atom bond. So into lapho ke it is ama-alcohol nama-carboxylic acid ngenxa yale bond le ya OH kanje. So anjalo nje, those are hydrogen bonds. So we move on. So check out what is the influence of type of intermolecular forces present between molecules of the organic compound on its physical properties. So check again manje ukuthi what are the effects intermolecular forces present with organic compound. So under weak intermolecular forces kukhonani ama-induced dipole forces nama-dipole forces, futhi under weak kukhona nama-London dispersion forces. So fall under ama-weak intermolecular forces. So kwenzakalani ke? They require little energy needed to break intermolecular forces, just little energy. If they are weak intermolecular forces, you require little energy needed to break intermolecular forces and let molecules move from each other. So injalo nje. And then low boiling point kanyanye ne melting point. So if there are weak intermolecular forces, less energy is required, and then in low boiling point iyaba khona lapho. And then if focus futhi nala to a little energy needed for molecules to break out liquid form vapor. So ichaza ukuthini ke leyo into? Ichaza ukuthi kuzoba na higher vapor pressure. Into ebalulekile la relationship, once there is low boiling point, that means vapor pressure izokhuphuka. So injalo nje, they are antagonist. So inkathi ungasho ukuthi they are inversely proportional. So when you increase boiling point, that means vapor pressure izo decrease. If you increase vapor pressure, that means boiling point yona izo decrease. So isebenza nje kanjalo. So if they are weak intermolecular forces, less energy is required to break the bonds, to break lawa ma intermolecular forces, hence ke lapho less boiling point. So enye into ofanele uyazi, omunye uyazibuza ukuthi kwayona leyo vapor pressure naleyo boiling point iyini. So wazi nalama definitions abalekile wenkathi ayabuzwa. So kuthiwani yokuqala vapor pressure, the vapor pressure is of a liquid at equilibrium pressure, vapor above its liquid, that is the pressure of vapor resulting from evaporation of a liquid above sample of a liquid in a closed container. So balekile nje uyifunde khona nakumanye ama textbook, ufunde summary le ithanda ukuba yinde kakhulu nakuma past exam papers, kanye ne boiling point, the temperature at which the vapor pressure of a substance equals atmospheric pressure. The stronger the intermolecular forces, the higher the boiling point. The boiling point of a substance is the temperature at which it changes from liquid to gas, change in phase lapha, and is reached when the vapor pressure above the liquids equals the atmospheric pressure. And then so the melting point. The melting point of a substance is the temperature at which it changes from solid to liquid. So siyazi leyo into leyo from nale graph le ekhombisa ama phases yaka grade 10, amelo or solid, liquid, gas. So you name them, I think gas and then solid. So if phase change ma diagram akhona, so kuyikhumbula leyo into leyo I relationship yakhona. So siyaqhubeka ke, if ke kade sikhuluma ngama weak intermolecular forces, kwi case la khona ke manje there are strong intermolecular forces. Lapho kuzoba njani ke, lots of energy needed to break ama intermolecular forces and let molecules move away from each other. So la sekudingakala more energy, sekudingakala lots of energy since there are stronger molecular forces like lama bonds la between mhlawumbe OC carbon, lapho kube no OH, ngenxa la example yakhona is hydrogen bond, and then lapho kuzodingakala more energy to break the bonds, hence ke lapho kuzoba na high boiling point. And then mesizo focusa with vapor pressure, lots of energy needed for molecules to break out liquid and form vapor. So low vapor pressure, since futhi nala energy, lots of energy is required. If there's lots of energy required, increase boiling point, hence you make increase boiling point, therefore vapor pressure is a decrease. So qhubeka kahle kwi video elandelayo. Qhubekeni ke sichazile relationship based kuma intermolecular forces. When there is weak intermolecular forces, that means there is little energy needed to break those intermolecular forces, and then hence ke lapho sekuzoba na low boiling point noma melting point. Little energy needed to break, that means high vapor pressure. So if there are stronger intermolecular forces, that means lots of energy needed to break ama intermolecular forces law, hence ke lapho sekuzoba ne rise kwi boiling point noma melting point. If there's a rise kwi boiling point, that means there's a decrease kwi vapor pressure. So a relationship nje isebenza kanjalo. Example yama stronger intermolecular forces, those are hydrogen bonds. So injalo nje. So let's move on la to our what is the influence of type of functional group that is found in the molecule on its physical property. In organic compounds where hydroxyl group are present, for example alcohols, carboxylic acid, you will find hydrogen bonds and induced dipole forces. Those are stronger intermolecular forces. And then in organic compounds where hydroxyl groups are not present, for example lapho kukhona ama-alkanes, alkenes, alkynes, haloalkanes, aldehydes, ketones, and then esters, you will find induced dipole forces or dipole forces. So lento it goes back kuloku okla ukuthi ke ahlukahlukana futhi kubuyele la ama-London forces, ama-alkanes nama-alkenes nama-alkynes, ama-hydrocarbons they fall under ama-London forces. So kanjalo kule category leya, so fanele uyazi ukuze ukwazi ukunema ngendlela nanokudescribe i-property yakhona. So wonke lawa akade ngiwanema ngenhla they fall under weak intermolecular forces. If they are weak intermolecular forces, that means there is less energy to break the bonds. If there's less energy, that means there is lower melting point. So iyabonakala nje leyo into, and then we focus to an less energy for molecules to evaporate. If there's less energy, that means there's a rise in vapor pressure. So energy nje encane nje ukuthi inga evaporator, that means it kuzo evaporator more. So there's higher vapor pressure, since lapha i-boiling point is lower, so high vapor pressure. So gelile once kwa increase i-vapor pressure, that means kwi-boiling point is a decrease. So size la alcohols, under alcohols nama-carboxylic acid fall under strong intermolecular forces. More energy required to break the bonds, and then more energy for molecules to evaporate. So if la more energy is required, that means there is higher boiling point kanye the melting point. La futhi if there is more energy required, that means there is lower vapor pressure. La in this case we increase a boiling point since there are stronger intermolecular forces. Hence ke mak increase a boiling point noma melting point, that means kwi vapor pressure is a decrease. So nje ihlala isebenza kanjalo, akwazi uku-increase kokubili. Once we increase i-boiling point, that means kwi vapor pressure is a decrease. Idalwe yini leyo? Kudala ukuthi there is more energy required to break the bonds ngenxa ukuthi there are stronger intermolecular forces. Example yama stronger intermolecular forces ama-hydrogen bond. Under hydrogen bond kukhonani ama-alcohols kanye nama-carboxylic acid. So there are several factors affecta ke manje i-property. So as focus manje kwi-chain length. So if there's a shorter chain length, if it's shorter i-chain length, mhlambe inosi kanje ine shorter chain length le, that means ina weak intermolecular forces, less energy to break the bonds. If there's less energy, once there's less energy, that means there's low boiling point, and then less energy, higher vapor pressure, since la i-chain is short. But in a case la khona i-chain iyinde, njenganje mhlawumbe kube pentane, la mhlawumbe la kube propane. So la i-chain yakhona is-short, that means less energy is required to break the bonds. If there is less energy to break the bonds, that means nama weak intermolecular forces. So hence again a boiling point ke lapho ke increase. So la kwi longest chain ke zoba na stronger intermolecular forces, and then more energy is required to break the bonds, higher boiling point. Since nje once kwa increase nje i-energy, that means ne boiling point is increase konke nje lokhu kujoyinene kahle kanjalo njengoba sibona stronger intermolecular forces, more energy, higher boiling point. Once there's higher boiling point, that means there's a decrease with vapor pressure. So injalo nje since la ku na longer chain. Into ufanele ukhumbule, once there's shorter chain length, that means weak intermolecular forces, less energy required to break the bonds, and then a low boiling point. Kwi longer chain, stronger intermolecular forces, more energy required, higher boiling point. So let us move on. Size la molecular mass ke manje, so compare between a molecular mass. So smaller molecular mass ke, more energy needed to move molecules away from each other. So la there's a problem la, so it's about less energy needed to move away from each other and break intermolecular forces. If there's less energy, that means there's lower boiling point. So iyabonakala kanye ne melting point. Greater molecular forces, if ne molecular force, greater molecular mass njalo, there is more energy needed to move molecules away from each other. So more energy results to high boiling point, less vapor pressure. So lawo ma comparison fanele nje uwazi ngenxa ukuthi ayabuzwa nje, applicable kakhulu. So let's move on to amount of branches. So ama branch la anama substituents. As the number of branches increases, ama alkyl groups go methyl, ethyl, propyl, etc. The shape of the molecular compound changes to more compact spherical shape with a smaller surface area. So as kuba nama branches amaningi could decrease the surface area, resulting in smaller contact area between the molecules and weak net van der Waals forces. So iyabonakala nje le into, as iba na more branches could decrease the surface area, hence ke lapho ke results to weak intermolecular forces or van der Waals forces. Molecules where carbon chains are branched should lapho less surface area and a less surface area. Lapho results to weak intermolecular forces. Where there is weak intermolecular forces, there will be less energy. Weak, less. Ihamba nje kanjalo. When it's strong, hamsana, no more energy. And then where is more energy, there's higher boiling point. So weak intermolecular forces, less energy to break bonds, lower boiling point and melting point, less energy for molecules to evaporate. If there's less energy, that means there's higher vapor pressure. Don't finally understand the boiling point. We beg utinjan once lower, that means we vapor pressure is decrease. So qhubekeni ke la, once njengoba ngisho ukuthi once energy ya less, that means ke lapho kuzoba na lower boiling point. Once energy futhi ya less, that means there will be a higher vapor pressure. Once check kakhulukazi boiling point, once boiling point yakho ya lower, that means there's a rise kwilento njana kwi vapor pressure. So nje into kanje, so asithi boiling point le, and then vapor pressure mhlawumbe si indicate ngo P. Kunale relationship nje, once kwa increase a low boiling point, that means kwi pressure kuzo decrease, since it is inversely proportional. So boiling point increase amakunjani if there is stronger intermolecular forces, more energy required to break the bonds. So la sesifocus ngithi manje kwi factor la khona ama branches emaningi khona ke. So more molecules with straight carbon chains, lapho ke kuzoba na stronger intermolecular forces, more energy to break the bonds, high boiling point. So yabonakala more energy for molecules to evaporate, hence ke lapho sekuzo decrease vapor pressure. Since uyabona there is high boiling point, hence ke vapor pressure izo decrease. Sebenza nje kanjalo. So let us do ama examples to summarize all of lento le ekade siyenza. Wazi nje ama factors affectayo i-physical properties. Siqale ngani ngama functional group, wa classify according to their weakness, are weak or London dispersion force nama dipole forces, are stronger ama hydrogen bond. If they are stronger intermolecular forces, more energy required to break the bonds. So siye kwi chain length na finally identify if is short chain length, that means there will be weak intermolecular forces, and then kanjalo siye la kwi molecular mass. If in a molecular mass encane, that means there is less energy needed to break lawo bonds lawo, hence ke nama intermolecular forces mancane lapho, they are weak. So hence ke lapho kuzoba ne boiling point encane. If ne boiling point encane, that means kwi vapor pressure izo increase. Kanjalo nje, it's the opposite of lokho okungenhla. Amount of branches nakhona, if ama branches emaningi, that means less surface area. If there's less surface area, weak intermolecular forces as a result. If there is weak intermolecular forces, less energy required to break the bonds. If there's less energy, that means there's lower boiling point kanye ne melting point. If there is lower boiling point, that means vapor pressure is increase using this relationship there. Once we increase the boiling point, that means vapor pressure is decrease. Once we increase vapor pressure, low uzo decrease. So nje isebenza nje kanjalo. They work inversely proportional. Okay, so let us do my examples 8. So yokuqala ithini, the boiling point of a branched alkene are lower than those of straight chains kade sikwenza ngenhla containing the same number of carbons atoms, because branched alkene chains have, if kuyi branch kwenzakala lapho kuzo decrease i surface area. So it's simple nje ukusheshe sikubone, without larger molecular mass ayingeni lapho, nalo angeni more electrons. This is totally out of order. So njengoba makhulunywa nje ngo branched no straight chain, lapho kusuke kuzocheckwa i relationship yani ye surface area. So i correct answer lapho u-D. So asiqhubeke. Which one of these compounds has the highest vapor pressure at room temperature? So yipi ezoba the highest vapor pressure at room temperature. So into soyichecka la, so check ukuthi yipi ezoba na weak hydrogen izoba na weak intermolecular forces. Once there is weak intermolecular forces, that means lapho ke kuzoba ne lower boiling point. If there's lower boiling point, that means in the highest vapor pressure. So yipi ke leyo izoba B. Correct answer. Yindaba singazange sithi propane ngenxa ukuthi phela propane yena uzoba, no, it's the correct answer, it's A. Ngenxa ukuthi sichecka i relationship yani ye vapor pressure. So la ethanol asimchuzanga ngenxa ukuthi yena una stronger hydrogen bond, or stronger intermolecular forces, more energy required, so hence in a higher boiling point. If in a higher boiling point, that means vapor pressure lapho izobe decreasile. Kanti propane yena una weaker intermolecular forces, and then abese aba yona ne in a higher vapor pressure. So siqhubeka, will the boiling point of hexane so be higher than or lower than that of pentane? So la ukubona a relationship la kwima chain refer to molecular structure, intermolecular forces kanye ne-energy. So kubalulekile need to explain, which I needed to explain your answer. So into yokuqala fanele u-indicate ukuthi ubani ozoba higher than omunye, with yiphi ezoba na higher boiling point. With hexane be higher than pentane. So hexane yena ukhishwa ubani? Hexane have 6 carbon, shuthi una 6 carbon kanye kanti pentane una 5 carbon. So hexane 6 carbon kanti pentane una 5 carbon. So hex and then la pent una 5 kanje. So check i-relationship yakhona ukuthi refer to molecular structure, intermolecular forces, energy. So siqale ke manje sibhale. So ngisho noma kuthiwa answer fanele u-answer ngale ndlela ke. Into ishoyo soqala ngokuthi uthi higher that's a mark, phela ngithi 4 mark, and then sesiya kwini kwi-structure, molecular structure. Suzo explain kwi-molecular structure hexane has longer chain length than pentane. So sungasho njalo ukuthi ke hexane has a longer chain length than pentane. So iyabonakala nje lento yokuqala. Khumbule phela i-question itheni will the boiling point of hexane be higher than pentane? So kuyashiwo ke lapha i-answer, it is higher than. Boiling point is higher than that of pentane. Higher than hexane has a longer chain length, and then this is alarm kuma intermolecular forces. Intermolecular forces phela ngithi fanele ukhulume nangawo. So another mark, and then usuzosho ke ukuthi between the different molecules of hexane you will have stronger or more intermolecular forces. Okay, siqhubeke angithi sichazile nge-molecular structure sesikuma intermolecular forces. Okay, kuma intermolecular forces into usuzoyi-explaina usuzosho ukuthi ke hexane, since phela ina longest chain length, hexane have stronger intermolecular force than pentane. So nje yabonakala imaki nje la eliba khona ilelo indicate ukuthi lo uzoba stronger than lo. Okay, then we go to energy manje. Describe energy ukuthi yona izoba njani. Phela ngithi question indicates ukuthi it's higher structure energy and then sizogcina ngayo energy. Okay, uhexane uzo require more energy is required to break intermolecular forces. Kubani kule structure lesi sa hexane. Hence ke nje usunga conclude hence higher boiling point. If there's higher boiling point, less vapor, pressure, less vapor pressure than pentane. But see, lo it's additionally equation yakho nje ubuzoyigcina khona la. You'll get a mark who indicates more energy is required to break intermolecular forces ku hexane, hence ku higher boiling point, to show ukuthi nje we understand. So every time uzo answer lama questions anje uyofocusa kakhulu njengoba nje guide question, focusa ku energy, focusa ku qale nje ngestructure. If ucomparishwa i-chain length yakhona kwenkathi kufanele uqale nge-functional group uyisho ukuthi enjani le, and then masudlula lapho uyochaza ama-intermolecular forces, and then bese uyivala nge-energy. So isebenza nje kanjalo. So ukwazi konke lokho njengoba kade ngikuchaza nje ngenhla, funda yonke nje lento i-understand njengoba uzazi wena, uyifunde yonke njengoba uyazi ukuthi kupho oku-greater than mekuzokhulunywa ngama-functional group kule case. So isiyafika i-question ke esibuza into enje. So sesiyichazile noku-understand ukuthi hexane ikomba i-structure esinjani leso. Hexane na 6 carbon and then ifola under ama-alkane. So la obvious comparison nje length, chain length la, and then understand yonke lo into. So size kule question le, how will boiling point of an isomer of butane compare to that of butane? Writes down higher, lower, or equal. Refer to molecular structure, intermolecular forces, and energy needed to explain. So la into fanele uyazi la sekukhulunywa nge-structural nge-isomer la. Well, into uzoyi-answer la usuzothi i-answer yakho izoba based kuloku. We'll just write down the answer. Well, angisebenzise enye indawo. So uqala uzosho ukuthi it is lower than, phela sikhuluma nge-isomer, that's a mark, and then bese uyasho ukuthi isomers of butane zoba nani, zoba na more branching. Phela ngithi isomer, it's the compound with same molecular formula but different structural formulas. So khumbula wonke nje lawa ma-definition, more branches okanye smaller surface area. Okay, and then mawusukhulumile nge-surface area Sizosho ke manje ukuthi ke weak intermolecular forces, and then masukhulumile ngama weak intermolecular forces usuzosho ke futhi ukuthi ke less energy needed to break ama-bonds. So naka nje ama-marks akho ukuchaza la surface area, chaza ngama-intermolecular forces, and then bese uchaza ngani nge-energy. If there's less energy, there will be less boiling point. So let us move on. So into ebekade trick la understand the isomer ukuthi iyini wayo ne-isomer. Consider the boiling points of compounds. Propan-1-all una 97 degrees, and then ethanoic acid una 118 degrees Celsius. So uyabona la i-boiling point ya ethanoic acid is greater than propan-all, alcohol. This is an alcohol and this is an carboxylic acid. So bathini ke la question, give a reason for this difference in boiling points by referring to intermolecular forces in each of these compounds. So answer kanjani ke le question? They both under ama-hydrogen bond, siyakwazi lokho, but khona a greater than omunye la in this case. Ngenxa yokubona phela i-boiling point ya alcohol ibonakala yi-less than eya carboxylic acid. So iyabonakala nje lento, so soyichaza kahle in the following video. Okay, right, uyabona la ukuthi i-boiling point yalo it's greater than leya carboxylic acid is greater than ama-alcohol. Two, give a reason for the difference of boiling point referring to intermolecular forces present in each of these compounds. They both have intermolecular forces, but ke khona i-difference ekhona kulawo. So qala sithini ke? Sithi ethanoic acid. So uyabonakala, siubhale nje kahle lo acid. Ethanoic acid unani yena una 2 sides for hydrogen bond. So yenye yama difference, since they fall under ama hydrogen bond, but kuhlukane ama sides akhona. So okay, and then sichaze ke ngobani ngopropan dash 1 all. Yena ithini ke i-answer yakhona inabani ina 1 side for hydrogen bond. So sayikhombile nje difference la 2 sides of hydrogen bond, 1 side of hydrogen bond. La alcohol, these are ethanoic acid. Ama-ethanoic acid ane greater boiling point. So asiqhubeke sisho ukuthi ke phela therefore more energy is required to break the bonds between ethanoic acid, phela 2 sides of hydrogen bond. Therefore more energy is required to break bonds for either Ethanolic acid. So yabonakala leyo into. More energy is required to break bonds for ethanoic acid, but first comparison alo propane dash, then propane dash 1 dash all. Sithi kuyi alcohol, sikubona kanjani ukuthi it's alcohol ngale suffix ya all, la carboxylic acid ngale suffix la oic acid. So iyabonakala lento engizama ukuyichaza la, 2 sides of hydrogen bond, 1 side of hydrogen bond, more energy required for ethanoic acid than upropanol ngamanye amazwi. Okay, molecules, then propan molecules siqhubeke. Therefore enye into usungaconclude ukuthi ke if more energy is required for ethanoic acid, hence more, not ngathi more, angithi higher boiling point kubani ku ethanoic acid. Higher boiling point ku ethanoic acid than upropan dash 1. Uqala ngani? Uqala ngoku-explainer ama sides of hydrogen bond. Ku ethanoic acid there are 2 sides of hydrogen bond. Ku propanol there are 1 side of hydrogen bond. Hence there is more energy required for ethanoic acid ukuthi break ama bonds than upropanol. Hence more energy, hence more boiling point ku ethanoic acid. So injalo kanye ihambisana ne less vapor pressure. So sometimes the question ingayibuza into ezo involve ne vapor pressure. Which one of the compounds propan, ethanoic or ethanoic will have higher vapor pressure? Oh, nansi question. Refer to their boiling points to give reasons. So kade ngomthetho nje ukuthi siqhubeke khona la. So if isi usubhalile konke lokhu usungasho ukuthi ke phela konke lokhu kuzoba i-opposite yalapha. So ngenxa ukuthi lo uzoba na higher, uzoba na less boiling point than ethanoic acid, that means uzoba na higher vapor pressure. So sesingasho ukuthi ke propan dash 1 uzoba na highest vapor pressure, since phela iyena uzoba na lower boiling point. So yabonakala, that's a mark yokuqala leyo. And then usungasho ukuthi ke yini isizathu saloko, because noma ngathi since have lower boiling point, and then hence if na lower boiling point, hence less energy required to break bonds. And then ke sungathini ke futhi ke so sungasho ukuthi ke more. So another mark ke futhi ke lapha ichaza nge-energy. Okay, and then also uchazile nge-energy sungasho ukuthi ke more molecules will present in vapor states. So logo ke if logo kuzokwenza njani, kuzo increase i-vapor pressure. So if there are more molecules in present kwi-vapor state, that will increase i-vapor pressure. So iphela kanjalo ke lama questions. So that's how you answer lama questions using all this information. So into yokuqala understand wonke lawa more properties. If i-chain length ingaka chaza ukuthini, if i-functional group inje kuzowenzakalani kuma intermolecular forces, kanjalo kanjalo ama branches. Okay, so nje iphela kanjalo le lesson yethu. Sesofocusa kwini, sesofocusa kuma